collaborative learning happening here, group learning. Did y'all finish it? Okay. So I'm going to show you how to do 4. So maybe I should have the 2 guys that figured it out do it. No. Let's see. So, for number 4, okay. So for number 4, we're going to use, it says it's a T distribution. Whenever it's a T instead of a Z, you have to find degrees of freedom is n minus 1. 10 minus 1 is 9. Okay, and it's a left-tailed test. So I have the picture there for you. So it's one-tailed, and it's on the left side. So if I draw a line here and make this 0.01, our T sub C is going to be here. Our critical value for the T distribution, down there. So to use the table, we notice that it's one-tailed, and T sub C, just like Z, looks like this. So it's negative to the left of the mean, so T sub C is going to be negative something. We have the, so we can use this chart. This is chapter 8, so we're no longer just looking at area in 2 tails. We look at the area in 1 tail, and the whole area in 1 tail is 0.01. We read down to degrees of freedom of 9, and the answer is 2.821. But we need a negative sign. So I gave this chart out. It's on the back. It's that paper. It's the back page of that paper. So anytime it's a T distribution, you have to find one more thing. The degrees of freedom is the sample size minus 1. That's why I gave you sample size. Because it's left-tailed, it's going to be negative. So you have to add a negative sign because the chart only gives you positives. And that's how you find it. So you'll have that table on the test, and you have that table now, so you can look at it. Take the quiz on chapter 8. It'll ask you that same question: how to find the critical value for T, how to find one for Z. So, did that make any sense? I don't know. Okay, it did. Good. Any questions on this? I have the answers posted in D2L. One thing people ask is you gotta get used to the fact that we have two areas in the tail, alpha and the p-value. Alpha corresponds with the critical value on the horizontal axis, and that's our charts say that. And on the first page, they told you the test statistic. So for this one you draw, and it was left-tailed. You have a test statistic, and so it's Z, so it's at negative 1.78. So this is your p-value. So we have p-value as areas corresponding to a test statistic. And that's from the actual data. They assume HO is true and run a test, and they come up with this p-value. It's a probability that you get a result like that, assuming HO is true. So if it's very low, if P is less than alpha, we're going to reject HO. If it's greater than alpha, we're going to fail to reject HO. So that's the p-value in the test statistic. And the alpha is an area in the tail also, but it's chosen to be small, especially if it's a medical decision, life or death, to prevent a type 1 error from occurring. But alpha is chosen for the problem based on the severity of it. If you're only interested in the percent of fiction books at the library, I mean, number 2 die if that number is wrong. So if you choose 10% or 20%, yeah. But so this is chosen, and then this is our critical value. But to run these tests, all you have to do is compare your p-value to your alpha when we start running them. But these are little skills that are worth just a couple points on the test and stuff. And they'll be on the quiz. So, and the answers to this are all posted in D2L under warm-up answers or something. Content. You guys all went and looked at the notes. I was so happy that nobody went and pulled up the answers and just copied them. All right, so you guys all get 10 points for this today. I have attendance. I know who did it, who came to class. So, all right, so we're going to go ahead. This is Chapter 8 notes. We were almost done. And I'm going to go through an example of each one, and then we're going to do more warm-ups. Maybe next time, if we run out of time. I'm not going to do I think I have these examples posted, worked out. I want to just do one example each time and let you do more examples and not spend so much time me having you fall asleep while I lecture. You know. Okay? Of course, if you have extra questions, you look at something that's posted and you don't get it, let me know. So here's how you do the whole thing. We're putting the whole thing together. The last page of the first page of our notes actually. Okay. The first page of our Chapter 8 notes actually told you these are the steps for hypothesis testing. Steps 1 through 5. That was the first page. We're going to be following these steps, and I actually want you to write on your paper 1, 2, 3. It's just much easier to follow if you write that. So you have to follow these steps. So our first step is write the hypotheses and label the claim. So you can just put a 1 and then HO colon H1 colon. But I was kidding. Really, the first step is to read through the problem and identify what it gives you and with the correct symbol. So, and I did show you an overview of Chapter 8 when we're doing these questions. You get to do your calculator, use your calculator. So, we kind of have Chapter 8. The most important parts of Chapter 8 are, this is posted online as Chapter 8 flowcharts. This is a concise, clear, short. This is what's the meat of Chapter 8. This is the overview. You want to know the overview. What do I really need to know? This is it. And it works just like Chapter 7, except now we're going to do those test commands in your calculator that you wondered about. Or maybe you chose those. So this is posted, and we talked about it last time. So we're going to be doing that. Let me go ahead and... So our step 1, it's been so really, we need to read through the question. The average credit card debt, so this is a mean, for college seniors is, and it says it has been reported, so this is mu equals 3262. with a standard deviation of all students' debts being 1,100. So this says all, this, so this is sigma equals 1,100. The student senate at a large university feels that the seniors have a debt much less than this. We could just check less than. So it conducts a study of 50, so that's our N is 50, randomly selected seniors, and finds that the average debt is $29.95. So that's referring to the 50 randomly selected seniors, so that's a sample, so that's X bar equals $29.95. With alpha equals 0.05, test the student senate's claim. Okay, so we're going to test the student senate's claim. They claim that their debts have their seniors have a debt less than the 3262. So the claim is mu less than 3262 claim. So did you all follow that? You got to read these problems and be able to pick out what it's giving you. Sometimes the claim's in the last sentence of the whole problem. See, this is the first time we've seen a whole problem. Before it was just giving you a claim and asking you to write it. So there's a whole problem. The problem gives us a claim and a population mean, and it gives us a sample mean, and we're testing this claim. So our first step now, after we've written all this stuff down, first we figured out, is it a mean or a proportion? We saw the word average in there, it's a mean. Yeah. Oh, we're going to do it in class. I didn't bring it today, so it's not something that you have to do at home. We're going to do it in class Tuesday. Okay? So good question. Yeah, we do have a worksheet due next time, right? And do we have a chapter 8 quiz due next time? In D2L. So there is I'm trying to find it. Oh. This is the worksheet that's due next time. 3 questions. Is this it? Is it? No, that's not it. That one. Okay, it's the one with the gas pump. Sorry. It's the one with the gas pump. Okay. Chapter 8, practice worksheet 1. 3 problems. You have to do 3 hypothesis tests. Okay? So, and who knows, I might have hints on there on what to use, but sometimes I leave them on there from previous semesters. So this does not have an equal part to it, so you put it in H1. And then you can just write, you keep the same symbol, you keep the same number, and you write equals. That's step 1. Step 2, is it normal or a t distribution? You guys, I heard somebody say normal. It is normal. Just write normal. I'm going to write down y because we know sigma. We know sigma. Do we know the population standard deviation, sigma? Yes. Then we're going to do a z-test, and it's normal. So step 3, we're going to do a z-test in our calculator. So we bring the calculator up, and we're going to go to z-test. So where's that calculator? turn it on, clear it. Okay, stat, tests, and these are all the ones I told you to skip last time. Okay, z-test. So the chapter 7 stuff were all down here, z-interval, they ended in interval. There's a z-test. We have statistics, we don't have a list of data, so we just use statistics. And I can make the calculator a little smaller and pull it down a little bit so you can see it. Is that better? Okay. Can you see it, or is that plastic in the way? No? Do I need to pull it down more? So then it's a little small. Okay. All right. We have statistics, so leave it in stats. I'll write that down. You don't have to write stats down if you want. And so then it asks for mu 0. It asks for sigma. It asks for x bar. It asks for n. And it asks for, and it says mu not equal mu 0, less than mu 0, greater than mu 0. And then it says calculate or draw. Okay. So see all the symbols. So it's important that you know which symbols, you should have your symbols memorized so that you don't have trouble picking all these out. Mu 0 is this constant here. And we're looking for less than mu 0. So we put 3262 in here. Sigma was 1100. X bar was 2995. N was 50. And here's where they're asking for what H1 is. They know HO is going to be equal sign, so here's how they tell what HO is. Here's how they tell what H1 is. We need the less than mu 0, so you highlight this, and then you can either choose calculate or draw. I like to choose calculate because the drawing won't work once we get into chapter 10 and we turn some stat blocks on. It messes it up. But if you're a visual learner and you know how to use the calculator, you can fix that. It looks like somebody's already typed in this for me. Isn't that nice? 2995. N is 50. Less than mu 0 and calculate. So if you choose calculate, it will tell you what test did you just run. It will let you check that H1 was correct, and it is, mu less than 3262. Of course, the calculator doesn't say that's the claim, but. And then here's the z-test statistic. So I want you to write to 2 decimal places. The test statistic is next. It's negative 1.72, and here's the p-value. I want you to write the p-value to 4 places, 0.043. Well, this one stopped at 3, but so if it's a 0 for the 4th place, you can leave that off. But there's and then it reminds you what you put in for X bar. You don't need to write that down, and N is 50. It reminds you of that stuff. So that's what I want you to write down. You don't have to write all of this down. I just did this for your benefit since I'm teaching it. Okay, so that's step 3. I don't make you write it by hand, but if you had to do the p-value by hand, this is what it would look like. You'd find z by hand with this formula we never used. And then you're going to find the p-value by doing normal CDF. it's left-tailed, negative 1,000 to negative 1.716. But you don't have to, this is by hand. I know, I got rid of that. I stopped showing you guys by hand. You can do it by hand, but I let you use the calculator, so you're gonna wanna use the calculator. Does anybody here wanna do it by hand? Okay, I thought not. All right, number 4. Step 4 is to compare the p-value to alpha. So I do want you to write p-value, make sure it's on the left, and write alpha. So the p-value is 0.0430, and alpha is 0.05. You need to make the decimal places the same number, so put the extra zeros there. And now you're going to compare, is 430 less than 500 or more than 500? Less than. Anytime we get less than, it's statistically significant, and we reject HO. It's unusual. So you have to write reject HO. This is where I said, so this is what I looked for step 4, and so then I cross out HO. So I can, I just cross it out so I can still read it to grade it. Don't scribble it out like, okay. And then step 5, the keyword, since the claim is H1, the keyword is support. So in step 5, there is enough evidence to support the claim, or there's not enough evidence to support the claim. Well, we didn't cross the claim out, so there is enough evidence to support the claim. That, and you have to write the claim in words. That the debt is less than, that the mean debt was less than, it's really talking about a mean, that the mean debt of college seniors it is less than 3262. Okay? So that's the whole problem. Get the calculator out of the way so you can see it better. So those are the 5 steps.
How do you know whether to use support or reject?
Okay, so you use the word support when H1 is the claim. You use the word reject when HO is the claim. That's exactly how you tell. Yes? No. That's the assignment.
Well, it's according to this stuff. It's like about this.
All right, you're asking about question 1 on the assignment. What, okay, I'll look at you.
I'm only asking because it's about what's going on here. Because I think people professional do they both be?
Okay. He's asking if these numbers up here in your hypotheses can be different. Class, what do you think? Can these be different numbers and still cover all our bases? One or the other has to be true. So it has to be the same number. And they have to be both. This, your claim is about your population. So whatever your population number is goes up here. So if your population number, I don't know which one was which.
Well, I knew they had to be the same, like that's, should it be 10 or should it be 12? Based on
Okay.
what it's saying in the.
So you
what-
have to pick the one that's talking about the population.
But it says, per day differs from 10, so, but it says, median 12, 12.
Okay.
Uh,
Where, does it say test,
Twelve is a random cell.
does it say test the claim that? Or does it say,
It says test the claim that the mean.
the
number of
claim
days.
is always about the population, so
So
the
it should be
claim
10.
goes in, your hypothesis.
Oh, it says 10.
Yeah.
Okay.
The reason it's not 12 is 12 is about the sample. We never put the sample value in the hypothesis, so, but, all right. So, any questions about this? You're gonna have to practice it. I do let you use your notes on this part of the test when you're writing these hypotheses. You can say, how can I do something? So, all right, what I usually do is, the next one is, it's another one about a mean, except this time, let me just identify what it's giving us. And you can look, this is posted. A simple random sample of 40, so n is 40. N is 40. This is extra information, what highway we're on, okay. The sample has a mean, so this is X bar. And it has a standard deviation of 5.7. So this is in the same sentence talking about the sample. So this is S. This is important. This is S and not sigma. S is 5.7. And then the question is the claim now. Is the mean speed of all cars traveling on Highway 105 greater? So the mean, the symbol, the claim is always about a population, so we use population symbol. Mu greater than the posted speed limit of 65. There's our claim. Use 5% significance level. So change that to a decimal. Okay, and so I have that worked already. Example 2, I have it all worked out. So I just want, showing you how to choose between S. So what kind of test would you do on this one? Because we don't know sigma, we only know S, but it's a test on a mean. We're gonna do a t-test. So on step 3, you'll do a t-test. But I'm not gonna work that whole problem out. You can try it and compare it with the posted answers. It's a t-test, and if you want to compare it, you should get a z equals 0.77 and a p-value, I think, of 0.4404. And try it and see if you get that, and if you don't, you can let me know. So, no, that's the M&M. It's still a t-test. The z is, oh, it's a t. We don't have, it's a t is 3.77, and we get a p-value of 0.0003, if you work that one. It is 2.7 times 10 to the minus 4 on the calculator. Remember, it's on the calculator, if remember the p-values of probability? P-values of probability. And if you get a number that looks like it's more than one, keep looking and see if there's an e negative something. This means 2.7 times 10 to the minus 4, which you move 4 decimal places over, you got 3 zeros, and then I rounded up to 3. My stat lab wants 4 decimal places on this, so for this answer in my stat lab you put .0003. In my stat lab, if you get an answer smaller than this, they just want you to put 0. Did you get that? Are you still working that one and asking if this is right?
No, I was gonna ask about calculator. I don't know.
Oh, yeah, we have to choose it differently than yours, but that's the alternate. I showed you, we already ran one test with it. So, see, we were choosing the alternate right here when I did that. It's just not labeled that way. That's the alternate. Okay? All right, we're going to go ahead. So look at that example and see at home and see if you can get that number. Example 3 is really, I'm going to skip that one too, because let's just go ahead and do 4. The reason I'm skipping these is I want time for you to work on things. You're not going to get it if I just stand up here and lecture. So let's do number 4. I have these filled in notes out there, so you should be able to see if you can get that one. Okay, so number 4, read through it. Is it a mean or a proportion? It's the first thing you need to ask. Is it a mean or a proportion? Does it ever say mean, or does it say average? No, so it's a proportion. If it has percents in it, it's probably a proportion. Okay, so for proportions, do you have to go?
Yeah, I broke my fingers on
Just now?
the No, that's right.
Oh, okay.
So the only things we need for next Tuesday are the quiz and the worksheet.
I believe so. And there's a self-evaluation after test 3 out there as well. Did you already do that? Okay. I'll try to remember to put a note out there. Oh, okay. All right, so if it's a proportion, we're either given x out of n or n and p hat. So let's look at this one. What do you think the 300 is? N, right? The bigger number is going to be n. Results from 27 subjects were wrong. X is 27. And successes of the results were wrong. It's whatever they're asking about. Use a .05 significance level. Alpha is .05. To test the claim that less than p less than .10 is the claim. Less than 10% of the results are wrong. Okay, so now we can find our p hat is x over n is 27 over 300. Let's see what that is. We don't really have to find p hat for this. Our calculator will find it when we do the one prop z test. But we can do 27 divided by 300. And that's .09. So our p hat is less than p. So why do we have to do a test? Can we just say it's less than? can't we just compare our p-hat with our p? What do you think, guys? Well, we have to know if it's statistically significant. And it's all based on that normal curve from chapter 6. So it depends on the sample size too. So the answer is no, don't just compare your p-hat to your p. It's based on, we're using the normal curve, the calculator command's using this normal curve in the background. Since our claim is less than, we're gonna have a 10% here. This is gonna be our proportions are always normal, so this will be our z-test statistic. Oh wait, p less than 10%. Oh, I drew this wrong. Sorry, guys. What are we doing in this test? We're assuming, let's just run the test and I'll draw it later. We're assuming that HO is true, so we're assuming that P0 is 10%. Then we're taking these values and putting it in, and we're getting something else, and it may not be 10%. Sorry about that. May not be 10% at all. So let's write our hypotheses. HO and H1. HO is P. Oh, okay. H1 is less than 0.10, and that's the claim. And it is more common for the claim to be H1. And P equals 0.10 is HO. There's our hypotheses. 2. Proportions are always normal. Proportions are always normal. So you can just write normal here for number 2. Number 3. Number 3, what's the, we're going to do a 1 proportion z-test. Okay. So we go to our calculator, stat test 1 proportion z-test. This is our P0. This constant here is P0. And we're looking at less than P0 here. So it's 0.10. X is 27. N is 300. We choose less than P0 and then calculate. I didn't write all that down. Do I need to write all that down? Is it in the filled-in notes? No. Does anybody need? Yeah, we have statistics. Oh, we won't have data. We don't have that choice on proportions. I don't know if you need to see this, that P0 and X and N, and X and N have to be whole numbers. And then it says prop. This is where we're choosing our alternative hypothesis. Either not equal, or less than P0, or greater than P0. And then I always just choose calculate. The draws you a nice picture. So this was 0.10. This was 27. This was 300. And we chose this one and chose calculate. But the calculate at least tells you what test you ran. I hit calculate, it comes right back. The first thing is we can compare our P less than 0.1. It drops to 0. Our z-test statistic, I need you to write that down. This is our test statistic. Next is negative 0.58, 2 decimal places. P-value, we want 4 decimal places. 0.2819 to 4 decimal places, I rounded. And that's all you need the calculator for. Notice it does give you p hat. We didn't really need to figure out p hat for this problem, but okay, so now we're going to do step 4. That's all we need the calculator for. Step 4, compare our p-value to our alpha. 0.2819 and 0.0500. And which way does that inequality go? Greater than. Anytime the p-value is greater than alpha, our decision is to fail, to reject, and you do have to write which hypotheses. It's always HO. Now the claim was H1, so we use the word support. So step 5. There is enough evidence to support the claim. Well, we need to cross out something. That's why I always cross out. Fail to reject HO means you don't cross out HO, you cross out H1. Okay, so we've crossed the claim out. So there is not enough evidence to support the claim that less than 10% of the test results are wrong. There is not enough evidence. It wasn't statistically significant. To support the claim that less than 10% of the test results are wrong. So now we can talk about what happened here, and I can draw a more accurate picture up there. What happened was that a sample proportion of 9% was not statistically significant. To say that the population proportion was less than 10%. That particular sample was less than 10%, but we're talking about the population here. So let's draw the picture how I should have drawn it. Is the p-value, we assume p is true, and then we convert to z. And so our p-value should have been 0.2819, a lot of area. It was ordinary data. So it was ordinary data, and so it is based on the normal curve, and it's based on the sample size has something to do with it too. If this had been a tiny sample size, like when we did the bunny activity, with only 6 in a sample, that was, we had quite large intervals. But this is good to have 300. Great. So that's an example of proportion. Does that make any sense? Is people still writing here? So on these tests, we can't just compare our X bar to our mean. That's just one sample. And the test in the background is using the normal curve or the p-distribution curve. So let's see. The other thing is so some more examples. Did you finish writing this? No, some is still on. Now let me look at the next page and see what we got. These take quite a long time to do all these examples. So maybe I should do one with a list of data, the last example on the last page. So look through, I think I have the answers posted for these, make sure you can do them. I can have you try one. Maybe I should just have you try a data one. You're just gonna put this in your list one. Okay, I'm gonna have you try one. Here we go. You're just gonna put the data in list one, and if it doesn't give you a population standard deviation in the sentence, you're gonna do a t-test on data. So let's see, I have some papers here. Oh, so this is the thing that's due. Next time. And I may have hints out there, I don't know. 3 questions that, and if you need more room, you can use that. So we're gonna do this hypothesis test form of t-test, given data. And we'll do the earthbound activity next year. Then we'll start chapter 9. It doesn't have it. Is that blank? Oh, okay. Oh, okay. I can, scan after, try to scan that and take a picture of, I can take a picture of that. And put it in Shelby. Oh, did you already print it?
No, you already did it.
Did I give it to everybody? Did I already give it to them? Oh, no, I just gave a choice to them. Okay. All right. This is the last thing we're doing today, and then we're gonna quit. This is gonna be worth 10.3. So, you get 20 cluster points from the class today. Work. The other group work. Do you think you should work together in group? Good. All right. And I don't have my phone with me I have those answers. Okay. You guys want me to just post it after class, or, I mean, I have. You already have the first one?
Yeah, it has a different one.
Okay, so we need the rest of these. Right? I probably am gonna be in a hurry, so I'll take to Shelby, I'll just take a picture of this. But I didn't bring my iPad. I could do it right now. I don't know what's that. Let's see, is that the? Oh, these are examples. Yeah, there's the race. And there's even another one. I used to have another example. Yeah. I don't have the answer memorized, so. But, okay, what did you do? Did you do, okay. Okay, so it was. Right, that's right. explain is the difference. Race and food included.
Yeah, actually,
Uh-oh, okay. And then, okay, so, did,
I knew the clean was the second one, I have that.
so it says gun is 100, this is X bar, so it's talking about the same thing. With the standard deviation of 20, so what's the 20? How do you know it's signal? Standard deviation is also X. So which kind of standard deviation is this? Referring to the sample, or is it the standard deviation of all? Is in the same sentence as the sample. So it's an F, so you only know F, take that.
Oh, so
No, it's still, the numbers are very close to D or T, but they're very close. The number being large might be explained by, X bar is not that much different than 10, you know, in the sense that, you know, the answer might be very similar.
So this is still my favorite.
Yes, and let me write there.
Just read it out.
Use that, and erase the p-value.
So that's not a signal.
Yes. So,
So,
yeah, in the same sentence and it's referring to the sample.
okay.
So, okay? And I just about everybody got that wrong on the test, but I had picked a problem that was so close on the question, that I had to count it all right. No matter if you did a D interval or a T interval. Okay. And let's see, I probably ought to work this. So you're gonna put, wherever it is, I'm losing my mind up here, guys.
But the T distribution, you do it to test.
Yes, that's when you do a T test for chapter 8. Okay. We're not gonna do the back to basics paper. Oh, for goodness. So you're gonna put that list of data in list 1. Here it is. And the reason we can work the problem is because the population's normally distributed. So you're gonna put this in list 1.
I got the exact same value. The fifth place is supposed to be the same.
Oh.
Yeah, it is.
Yeah.
I believe it. It's statistics, 7%. And then chose stats. Yeah. Okay, so next.
Yeah, slightly different. Yeah, totally
Yeah,
close.
it's very close, but it's different.
Yeah, it's different on the third and fourth place. All right, so type in, did you guys type those in? I don't think I brought my to this. You ever figured it out? Great. so everybody's, this is 10 points, so I wanna see if you got it. Put your data in list one, and, like, those numbers look right, but then these two. The decisions, you always compare the very, the p-value and how. Okay, so the p-value is 0.064. And our alpha was 0.01. And then this step we're just comparing. But how do you find it? It's ordinary data, so it's family.
So you list it all.
We're always going to make those decisions. So, we also do that. Is that little, if the null is low, if P is low, reject the null, and how's that supposed to be? And if P is high, let it fly. So if the P is higher than alpha, so you fail, reject it. And then if it's less than, that was on the warm up, that was where on the back page where I asked, if they ended up all being like, it's gotta be, you have that warm up there? I have, my problem there. Oh, really? Okay. So it's this part, oh, you have, you compare this step four, you compare the P value and alpha. And the P is low, then alpha is go. So this is 0.25 compared to 0.01. That's less, so, reject.
So we remember this number.
If that greater than will fail, I could change the one. But also, but anyway, if the P is low, then no one says that, because you either reject, you always reject it, or you fail. So I always have right, that P value is less. And the alpha, right, and there's times ordinary data. Then you're gonna interpret the decision, it doesn't explain, it results. So the family actually shows the problem.
It's gonna be the same place.
Okay? And then it doesn't, yeah. And then we're in this court. So there is enough evidence for the person, no, there's not enough evidence for the person. There's not enough evidence.
Less or greater than alpha.
And less.
Like support.
Okay.
enough evidence to support or not enough
All
evidence to
right,
support.
guys, good class, wait a minute, is that your help? You got it? There's not enough evidence, you got it. You got it, it's not normal. Your T is negative 2.66, right?
Yeah.
Get that?
She takes a lap. Here's the answer, here's what she does. Here's the answer she goes.
I didn't write much down. You get that up, you got a little more. It might not, okay. So you put this in one.
Oh, all right. I guess the N would be 666. I guess N is gonna be a sample, would be this sample of 6 inches.
You guys get that?
I just wanted you to check it so I get it.
Yeah, yeah. And I, of course, that's bad.
It's probably wrong.
Yeah, you do have to.
Oh, it's all right, I'm just trying to,
Yeah.
I'm gonna try and get it around.
Good,
Yeah, I
good job,
figured,
good job, good job, guys.
I generally do, but I
Making
don't
any
think
sense?
it's-
Good. I'm trying to explain it in a short and concise manner.
I have a question.
Okay.
My guess is that this is just a sample, right?
Yeah.
This is a sample of the N being 6 inches.
Right, you cannot use it,
So this is the T is from there.
right.
All right, thank you, that's all.
I'm sorry. Literally like a minute. It takes me 3 minutes to get here every day. And somehow I'm like, every day.
Yep. Yep.
Okay, that, when you live further